This Zoom session is being brought to you by the Fractal Bullseye Fire. Okay, today we're going to be doing two sections, and I believe this will be the last time we'll be doing two sections this semester, though maybe I'll throw in a couple later on. And these will cover inverse sine, inverse cosine, inverse tangent, and other inverse trigonometric functions. Oh, by the way, this is also covered in the module, in the extra credit modules I'll show you later. Okay, fine. Inverse sine, inverse cosine, and inverse tangent. Well, the idea is that we want to write an inverse of the sine. So the y is called arc sine of x or sine inverse of x, if and only if sine of y equals x. What you do is you draw a sine function snaking up the y-axis rather than the x-axis. Then we take this little piece of the graph, and that's a graph of a function if you just take this little piece of it, and this is its graph. Another way to look at it is that we draw a unit circle, and to find the arc sine of x, we go a distance x, in this case negative, and we draw a horizontal line, and we see where we go, where that winds up on this right half of the circle. And that angle y is the arc sine, usually given in radians, though of course you can convert to degrees as well. And in fact, your calculator will probably have arc sine and modes for degrees and radians. So you should always know which mode your calculator is when you use the arc sine or the arc trig or the arc cosine or the arc tangent. Okay, so. And sine of arc sine is always x for any x in its range, which is between -1 and +1. Arc sine of sine x is x if x is between minus pi halves to pi halves. For outside of that, it kind of looks like a sawtooth wave, the graph of arc sine of sine. Now here we have the arc cosine, also written cos inverse x. That y is arc cosine if cosine y equals x. Its graph looks like, well, we take this cosine graph and make it snake up the y-axis, and we take this little piece of the graph here, defined between -1 and 1, and a domain from 0 to pi radians. Here's how we do it. We take the unit circle, and to find arc cosine of x, we go a distance x along the x-axis, in this case negative, and we draw a vertical line and see where it meets the upper half of the circle. And so this angle here is the arc cosine. Then there's arc tangent, or written tan inverse, y equals arc tan x if tan y equals x. And again, we draw the tangent function zipping off, making these S-shaped curves up and down the y-axis, up and down the plane. And then we just take this branch of it, and this is the graph of the arc tangent. It's defined for all values of x, and its range is from minus pi halves to pi halves. Here, the way we define it is we draw a line, vertical line, tangent to the unit circle. We go distance x, in this case negative, and we draw a line from the origin to where this point is. And wherever it meets on the right half of the circle, this angle y is the arc tangent. So, for example, what is the arc sine of -1? Well, we go down -1 units, we find it here, and that's not negative pi halves, negative 90 degrees. Arc sine of √2 over 2. Well, we go over √2, up √2, out √2. This is an angle whose sine is √2 over 2, and it's a 45-degree angle, or pi over 4 radians. Arc tangent of -0.4. Well, okay. This is where you run to the calculator. And I see now that I did this by first this -0.3805, etc. Let me double check that, because that looks like it's in radian mode. Arc tangent of what's it again, -0.4. Yeah, -0.38. It's 05806, etc. That's if it's in radian mode. If it's in degree mode, that corresponds to -21.801 degrees. All right. Arc tangent of √3 is what? Well, we go over 1 and up √3, and this angle then is is the arctangent. And it's a 1√3 triangle, which puts a 60-degree angle here. So the arctangent is 60 degrees, or pi over 3 radians. Now, similarly, we're going to do arc sine of negative 0.12. Again, I'm assuming we're doing this by radian mode. And just run to the calculator, inverse sine of negative 0.12. And yep, negative 120289, etc. Now here, this one, they say inverse a function. Well, okay, I'll find an inverse. The problem is, of course, that with sine, it's many to one function, so they're really many inverse functions. But we'll find the one, just the main one. So, okay, invert 5 sine x plus 2. So we want to find y equals f inverse of x. So that's true if f of y equals x. So f of y is 5 sine y plus 2. That equals x, and we'll solve for y. First, we subtract 2. 5 sine y equals x minus 2. Then we divide by 5. Sine y equals x minus 2 over 5. And then y equals arc sine x minus 2 over 5. There are, in fact, many such inverses. But this will do. I'll accept this one. Solve 4 arc sine x equals pi. Well, divide by 4. Arc sine x equals pi over 4. All right. So therefore, x is the sine of pi over 4, which is, if you do it, √2 over 2. Here we have 4 arc cosine x minus 2 pi equals 2 arc cosine x. Solve for x. Well, okay. We transpose the 2 pi to the right and the 2 arc cosine x to the left. So 4 arc cosine x minus 2 arc cosine x equals 2 pi. Combine like terms. 2 arc cosine x equals 2 pi. Divide by 2. Arc cosine x equals pi. Take cosine of both sides. X equals cosine pi, and that is negative 1. Okay, that's it for there. Stop recording.